Alright, on another CCS here, I went ahead and built this one up, which is a constant current sink. But instead of using the 2908 or 2222 transistors, I used the 3904s for this one, with pretty remarkable results. I've honestly never seen a constant current source quite this good. Let's see. Geez, I don't know if you can. I don't know if that helps or not. These wires. Okay, so you can kind of see the ammeter there, and you can see the voltmeter. Right now I got it at 0 volts, right? And you can see, oh, and here's the circuit, by the way. So it's very similar to the last one. It's just got, two transistors, just different transistors and a different configuration. So you can see the current reading is negative, on my meter, because I never changed the lead direction. So, but it is a current sink, so why not, right? Okay, so let me show you what happens. It's got my resistance box here. I got it set to 0 pretty much. That's what we're getting the result we are. Okay, so let me show you how the reading changes. I really can't do this easily with one hand, but notice what the current is on it. So, going, clear up to, I went too far. Anyway, going clear up to, certainly 21, 23 volts or so, even 25 volts is 21, 30.7. Let's go back down to 0 real quick. So it was 30.7. It decreased by about 2 microamps over a 25 volt range. I mean, that's just wholly remarkable. I mean, orders of magnitude better performance than the last one I built with the 2222s. Maybe I got lucky. Maybe the things are like matched or something, but again, they're just randomly selected. And you can see what the results are when I went ahead and ran a series on it, of, on my decade box with different voltages, like you can see here. Let me try to make this a little neater. This one too. Okay, so anyway, but yeah, you can see the current variations and so forth, and and here are the resistances it was coming out with, but these are with incremental, measurements, just like before. In fact, the previous one, if you recall, the constant current source, gave us these results, with a 1.38 mega ohm average, right? But this is giving us only 2.94 mega ohm, which doesn't look that remarkable. But boy, this thing varied, good 20 microamps over this range versus like 2. It should be 10 times better. And in fact, if you actually take a more extreme resistance measurement of it and figure out, oops, that's the wrong one. But no, not 20 microamps. Let's see, it varied over 12 microamps. 12.4 microamps, over the range of that previous configuration. And again, if you work out the extremes, like I said, you can see what the, resistances were. It's 1.3 mega ohm was the average. But if you actually take the extremes, between these voltage extremes here, the min and max versus the current extremes at 12 microamps, and work it over a broad range, it's actually going to be more accurate because you're going to get more variation in it and less, microscopic changes in the damn thing, as opposed to a very broad variation. You see it more clearly what it actually is. Because again, I kind of suspect at these lower levels you're dealing with such low resistances. I think the accuracy of the instruments isn't so good, so I just think it has a harder time detecting those differences. Again, if I had Keithley test equipment or something, Keithley test equipment, I could probably get much better, much more accurate readings. But that's about the best I could do with what I got. But anyway, if you do it over a broad range, it comes out to about 21 mega ohms for the previous one I did. This one you do that exact same calculation, even though its average was only about 3, it's actually like works out to 121 mega ohms, which honestly, given what we just visually saw there, I would say that seems pretty fucking accurate to me, given the variation, being so small. Again, I've never seen a constant current source quite that stable. I mean, it's down to just a couple of, microamps. That's pretty damn accurate. That like is a keeper. I'm going to have to build that up into some kind of a project because that's way better performing than that last one. Try to put it on some kind of circuit board. But anyway, I intend to do the this one. In fact, that's what I was doing, but I was having problems. I think because these JFETs, these MOSFETs of mine have been laying around in a plastic drawer for like 20 years. So I have a feeling that they're probably not good, but I don't know. A couple of them tested so far, but apparently one of them blew out, even though I didn't actually hook the power up to it. But I probably got to back the voltage down to like 20 volts or less, because again, its gate voltage is going to be an issue there probably. So most FETs are 20 volts or less for the gate voltage. This may even be worse. I really had to look up the data sheet. But I was going to start at like 15 volts, and that's what I kind of tried to do, but apparently I blew the first one out somehow. And then I tried to hook in the second one up, and it didn't work for some reason. And I had to try to, change it out with a transistor, 2222. That didn't work. And then I find out, all along I had it hooked to my stupid analog discovery pin instead of the power supply pin. So I wasn't applying power to it, but still the FET I took out tested bad. So I guess it blew out in the process of me assembling it or some shit, even though I'm strapped up. So anyway, go figure. But I'm surprised any of these FETs test good, period. Because again, plastic drawer, 20 years at least. So, but at any rate, I'll try to do something with this. I'll probably keep these transistors and just rebuild the circuit, because I do want to build this into an actual board, because that is remarkable results for a constant current source. I mean, I've got to hold on to that for testing purposes. Anyway, that ought to about do it. Cheers.